What actually kills you in a supernova? Most people would guess the explosion. A wall of fire expanding outward at thousands of kilometers per second, vaporizing everything in its path. Sounds right. Others might say radiation. Gamma rays cooking you from the inside out before you even knew something was wrong. Both answers seem reasonable, and both are completely wrong. If a star near Earth went supernova, you'd be dead before the light from the explosion ever reached your eyes. Dead before the radiation arrived, dead before the shockwave even left the star. The thing that would actually kill you is something you've probably never heard about. Something that passes through your body by the trillions, every single second, without you noticing. Neutrinos. These are ghost particles, and they barely interact with matter at all. Right now, about 70 trillion neutrinos from the sun are passing through your hand every second. They go straight through you, straight through the Earth, and out the other side without touching anything. You could put a wall of lead a light year thick in front of a neutrino beam, and more than half of them would still get through. They're essentially unstoppable. So, how could something that ignores matter possibly kill you? The answer is scale. When a massive star dies, it doesn't just fade away. The core collapses in on itself so violently that it triggers a runaway chain reaction. In about 10 seconds, the star releases more energy than our sun will produce in its entire 10 billion year lifetime. 99% of that energy doesn't go into light or into the explosion. Almost all of it goes into neutrinos. A supernova is basically a neutrino bomb that happens to also produce some light and debris on the side. When those neutrinos blast outward from the collapsing core, they travel at nearly the speed of light, and nothing slows them down because nothing can stop them. They race ahead of the light, radiation, and the shockwave, carrying almost all of the supernova's energy directly toward anything in their path. At normal distances, this doesn't matter. When a star explodes thousands of light years away, the neutrinos spread out so much that they're harmless by the time they reach us. We actually detected neutrinos from a supernova in 1987. It was 168,000 light years away, and a few dozen neutrinos hit our detectors over about 10 seconds. No harm done. But move closer and the math changes. Fast. If a supernova happened at the distance of our sun, the neutrino flood hitting Earth would be roughly 10 quadrillion times stronger than normal, and the energy packed into each neutrino would be about 10 times higher than the ones our sun produces. When you multiply those numbers together, you get a result that actually matters. Even with their incredibly low chance of interacting with matter, enough of them would connect. The energy they dump into your body as they pass through would be enough to boil you from the inside out. Every cell in your body would absorb lethal radiation at the same moment. The whole process would take about 1/20th of a second, which is faster than you can blink. The scariest part is what the timeline looks like. In 1987, when that distant supernova went off, our neutrino detectors picked up the signal first. The light from the explosion didn't start arriving until hours later. The neutrinos beat the light by hours because light has to fight its way out through the outer layers of the dying star, while neutrinos just leave immediately. So if a supernova happened close enough to kill us, here's what would actually happen. The neutrinos would arrive first. In a fraction of a second, every living thing on Earth would already be dead, boiled from within by particles we can't see, feel, or stop. Then, hours later, the sky would light up. The most spectacular explosion in the universe would finally become visible, but there would be no one left to see it. You might think, well, maybe we could hide, get underground, or put the planet between us and the blast. Nope. They wouldn't help. Neutrinos don't care about planets. They pass through Earth like it isn't even there. The far side of the planet offers no protection. A bunker offers no protection, and nothing we could build offers any protection at all. If the supernova is close enough, every single location on Earth receives the same lethal dose at essentially the same moment. The entire planet simply dies together at the same time, or separated by fractions of a second at most. Now, for some good news, there are no stars close enough to Earth that could actually do this. Our sun isn't massive enough to go supernova at all. It will die eventually, but it will swell into a red giant, and then fade into a white dwarf. No explosion, no neutrino burst, and nothing for us to worry about for billions of years. The nearest supernova candidates are hundreds of light years away. At that distance, we'd see a spectacular light show, but the neutrinos would be too spread out by the time they reach us to cause any harm. We're safe. Probably. But somewhere in the universe right now, a massive star is reaching the end of its life. In a few hours or a few days, it will collapse. A burst of neutrinos will race outward at the speed of light, carrying almost all of the explosion's energy into the darkness. If there's a planet orbiting nearby, anything living on it is already doomed. The ghost particles are already on their way, and by the time the sky lights up with the most beautiful explosion imaginable, there won't be anything left to watch it. That's the thing about neutrinos. The warning and the death arrive together. You see nothing. You feel nothing. And then you and everything you've ever known will be gone. If you want to keep thinking about the things the universe doesn't want you to worry about, subscribe, and I'll see you in the next one.